In this video, we're going to cover how to rig up gears using gear ratios. This is a question I've gotten a few times now, and I haven't really addressed it because there's not much to rigging gears actually. Um, let's go ahead and look at this guy. And you can see if I turn this one, the others are spinning and they stay in sync. And it's nothing special. It's a multiply divide node saying this gear rotates a percentage of what this gear is rotating. And same here, this gear is a percentage of what this gear is rotating. The math is just really simple, basic multiplication. I think the thing that probably catches people on gears is just not understanding how gears actually work. And often what I see is there'll be a big gear over here with big teeth, and then there'll be a tiny gear over here with tiny teeth, and then here's a medium-sized gear with medium-sized teeth. And people are trying to figure out, how do I make these all rotate together so that they fit together? And that's not how gears work. If you notice, all my teeth look like they're about the same size because they are. Gear ratios work by having teeth that are the same size fit together, and that changes the speed at which different wheels rotate. Really, the key to making gears is knowing the math of how many teeth each gear is supposed to have, and then how big the radius is and how fast that'll make it rotate. And there's different ways to approach this depending on if you need a certain speed, like if you're trying to make an engine simulation and actually get rotation at a certain speed, or if you're just trying to get the visual niceties of it, that's much easier to do without quite as much math. But what we're going to do here is I'm going to show you how to build these so that you could get working gears and a little bit of the math, just kind of the basics, so you start to do this. Now, some people hear math and they get a little bit scared. It's basic algebra, geometry stuff of, like find the circumference of the circle, do a little bit of math. It's nothing super complex. It's just understanding how gears work. Now, part of it is gear ratios, which if you look, do a Google search, you'll find a ton of stuff on. This isn't anything new and it's not that complicated. But like here is a ratio of here's how many teeth on one gear and teeth on another gear, and here's the speed difference ratio of where they intersect. So we'll use this in a little bit. We'll come back to this. But we're going to start off making a basic gear that's just extruding a cylinder, and you'll see kind of the process here. So I'm going to go ahead and make a new scene. And we'll make our first gear here. I'm going to make a polygon cylinder. And I'm going to get an extrusion history. I'll leave the radius at 1, turn the height to 0.4, and I'll leave the subdivision axis at 20. And I'm going to go into component mode, select every other face, and then I'm going to extrude these faces out to make my gear teeth. And the key to making my gears work together is making all my other gear teeth faces the same width as what I have here. So let's go ahead and extrude this. I'm in my polygon editing mode. Edit mesh, go down to faces, extrude face. Make sure you're down in faces if you're not familiar with modeling, otherwise you might extrude verts or edges, which is not quite what you want to do. I'm pulling this out straight out in Z, just a little bit here, and then I'm going to hit scale in X. I'm grabbing the box at the tip of that. And then over here, I'm going to set values so I can get the same length and tapering on all my gear teeth. So I'm going to use 0.35 for the length and 0.8 for the taper amount. So there's my first gear. Now what I want to do is I want to build a bigger gear like I had before, and to keep the math simple at first, I'm just going to double the amount of teeth. So I'm going to go ahead and make another cylinder. I'm going to pull it off the side here, and to double the teeth, I'm just going to double the subdivisions. I'll turn my height back to 0.4 again, so it's the same height. But now I need to figure out what the circumference is to keep the width of those faces the same, or my radius more so. So for that, we have to do some basic math. And first off, I've got to figure out the circumference of this gear I made and how big the faces of the teeth are. So I know when I made this, the radius was 1, and I did 20 subdivisions, so it's divided 20 times. So I'm going to open up WordPad here. And if you don't remember your basic, is it algebra or geometry? I'm going to say geometry. The way you find the circumference of a circle is 2 times pi times the radius is the circumference. So knowing that, we can start to do our math. Now, really, what we don't want just the circumference. We need to know how wide each one of our teeth are so we can work backwards from that. So the way we do that is first find our circumference, 2 times pi times r, and we divide it by the number of subdivisions we have, SD, for subdivision, which was 20, to find the width of each one of those faces. So I've already written out the math here. So 2 times pi, 3.14, we could simplify it, that's close enough, times 1, that was our radius, divided by 20 subdivisions will equal our width. So let's go ahead and do that math down here. I'm going to open up my calculator. And so let's go ahead and type it out first. 2 times 3.14 times 1 divided by 20 equals W. So let's figure out what W is. So 2 times 3.14 times 1, I'm not going to type that in because that would still be the same number, equals that, divided by 20, so 0.314. So that's how, let's go see if we make this wider. All right, let's make this smaller so it all fits. Okay. That's the width of each one of our faces. So now we need to work backwards from there to figure out what our new radius needs to be if we make more teeth. So let's, I can't remember if I said this already. Yeah, so we're going to double the amount of teeth. So we know, let's go ahead and write this again. So starting with, if we want to, well, let's go over some basic multiplication. If we want to reverse this equation to single this out to say, you know, this is really r. We need to figure out what r is. So let's work backwards. So if this was multiplied over here, we could cancel it out over here and add it on over here by swapping it. So if we times 2 over here, we could divide by 2 on both sides and still get the same equation, which ends up being essentially just switching these over by dividing. There's probably a more elegant way to say that, but I am not a math teacher. I'm going to go ahead and change my font size down a little bit first again. Okay. So 0.314 divided by 2 divided by 3.14. I'm going to skip r because we want to leave r over there. And we divided by 20 before, so we're going to multiply now. But actually, 20 was the number of subdivisions we had, and we now have 40 on this new gear we're making. So we're going to multiply times 40, and that should tell us the radius we need. So let's go ahead and do this math. So 0.314 divided by 2 divided by 3.14 and then times 40 is 2. And I knew that going ahead of this because that was easy math to do compared to some of the other options we could have done. So I'm going to move this off to the side and extrude out my teeth, and just to make my life easy, you can kind of see, because this is double, this lines up pretty well. So I am going to make sure I pick this face starting in here, which is already kind of pointing into that space, and that should make things line up a little bit easier and put a little bit less guesswork into figuring out how to line these things up once they start rotating. And I am just going to select every other face again and then extrude these out the same way I did before, using the same values. So my teeth again are the same length and the same tapering. You could probably have those slightly different, but again, this is just going to make it work so much better, having everything be the same. And again, usually that's the problem I see is people just don't understand how gears work and built gears that would just never work in the first place, and then try to figure out like, well, how do I rig this up? It must be some mystery of rigging, and no, it's just you built it wrong, so it can't work in the first place. So there we go. So we got our second gear here, and I'm just going to move this over this, over the side a little bit more. And that's, yeah, that fits pretty well to start with. It could probably be rotated a little bit more, and that part I tend to just eyeball and freeze transformations on things, but we're going to skip that for right now. So how do I get these to rotate in sync? It's pretty simple. So because this is double the radius and double the teeth, this math is still pretty simple for the rotation. It's going to rotate twice as fast as this one does. So I'm going to open up my node editor here. And I've got both my models selected when I load it up, so they are both right here. So I'm just going to stick these off over here so I have them. And I'm going to create a new node. So I'm right-clicking, create node. And I'm going to want a utility node. And where's my multiply divide? There it is. And I'm not naming anything because I'm rushing through this. You should always name your stuff, but do as I say, not as I do right now. So rotate Y. We're going to hook up the rotate Y into this multiply divide node, into the input Y. And let's see. Since this gear is bigger, it's going to rotate slower than this does. So because it's twice as big, it's not actually, we don't want it to spin twice as fast. We want it to spin half as fast as this. So I'm going to say 0.5. It's really a smaller gear that would spin faster. So, and I'm going to say negative 0.5 because they're going to spin in opposite directions. Really, I just need the 2Y here, but I just so used to selecting them all, so I don't screw that up later. So I'm going to take the output Y of this and hook it up into the rotate Y of our second cylinder. And that's all that's going on there. Let's go ahead and move these conversion nodes in here. That's just it doing math in between. So, hey, take this, cut it in half, and put it on this one. So let's look at what happens when we rotate this gear now. That looks pretty good. So what happens when we want to do more complex math of like, hey, I don't want to just double this. I need to do a specific size. So let's go ahead and create another polygon primitive here and make another cylinder. I'm going to move it up here, and then I'll have the big gear driving this. And we'll change this to 0.4, and let's figure out how many subdivisions we want to do. So let's look back at that little chart that I brought up. So this is teeth, but I'm actually going to count the spaces because we're going by subdivisions. So the one I currently have is 40. So let's do it by, let's do 15. So, and you may watch me screw this up because I'm not great at this. Not a math genius, just enough to hurt myself every now and then and get through by trial by error. But that's how we learn. So that's my gear ratio. That's my speed in churning. That'll be the difference. But I'm going to go ahead and start with 15. So 15 subdivisions instead of, oh, wait, do I want to do 15 or do I want to do, no, let's do 15. Let's actually do 15 subdivisions. Let's see how this turns out. And this part's a little bit unrehearsed. I usually do a dry pass, but I'm doing different numbers this time. So let's open back up our equation here. And we're going to take our same equation as before, but this time we don't have 40 subdivisions, we have 15. So I'm going to swap that number out. And I'm going to get the calculator out so I don't make any mistakes, hopefully. 0.314 divided by 2 divided by 3.14 times 15. And I don't have that equals because these are all division and multiplication. Remember your order of operations in algebra and math and all that stuff. Because these are multiplication and division, it all happens in the same order. Now, if there's a plus or something in there, we'd have to do the multiplication and division first and then do the addition. But we could just do that all at once. So a little math refresher. Let's hit equals 0.75. Actually, that's way easier math than I thought it was going to be. So that's my radius. So let's go ahead and type in 0.75. Okay, so that should give me gears that are the same. Wait a second. 2, 3. Yeah, no, that doesn't work. Because I'm doing subdivisions and not actual teeth, 15 is not a good number to use because I will have two teeth right by each other. So let's change that. Let's go to 16 and make life a little bit easier. I probably should be counting my teeth, but if you happen to notice the chart that I happen to grab, let's see, would it do 10 and... No. Yeah, let's just do it by that. Even if I double it, this should still work out. So, so we have 16 there. Let's go ahead and do our math again. See, learning. I mean, that's a good thing to point out. So if you're counting by subdivision and not just your teeth, keep in mind you need even numbers, otherwise you'll have two teeth by each other. So let's type in our math. Whoa. No? Okay. 0.314 divided by 2 divided by 3.14 times 16, 0.8. Still pretty easy math. Okay. So let's go ahead and grab every other face again and extrude them out. And mesh, extrude. Oh, yep, did the wrong one that time. I did vertex edge. So face, extrude. And again, just hand doing those so I can see which numbers to type in quickly. 0.35 was the value. And again, you can use whatever value you want. They just need to be the same. I'm guessing if they get too long, then they probably can't rotate into each other easily. But you know, look at gears. It'll be pretty self-explanatory when you start looking at enough examples. Okay, so we've got our new gear here. That looks like it's right. Again, I am no math genius when it comes to this stuff. And there's probably a better way to line these up. I don't know what it is, but that doesn't look like it's going to quite line up. I'm going to cheat here a little bit and just rotate this to line it up with about where that tooth is. So it's kind of those two faces are parallel. Now this is the part where I'm not super savvy at knowing how you might fit these together to fit better. But we're going to eyeball it and call that good. Let's do that. Okay. So I'm going to go ahead and freeze transformations on this. Really, I just need to freeze rotations, but we'll just freeze the whole thing. And I'm going to go make sure I zero. Actually, haha. Let's do that again because I didn't zero my original gear out. So when I connect this up, this would have moved immediately and not been in the same position. I think I moved it up a little bit, but whatever. It's a demo. Okay, freeze transformations again. Okay, we're going to call that good enough. And I'm going to grab these two gears again, open up my node editor, which is down on the screen, and make this a little bit bigger. Going to go ahead and create another multiply divide node. And I'm not certain on the math yet, so let's just hook these up first. So this will be driven by the rotation of the bigger gear, so rotate Y. So we plugged into input 1. And then the output of Y will be put into cylinder 3. Okay, so now we need to figure out the math. And again, let's go back and look at our chart. And we have 40 subdivisions to 16. So in theory, it's still easy math. Okay, so 2.5. And because this is small, this should be rotating faster. It's going to, need to do more rotations to fit with those teeth of this bigger cog. So, oops, let me open back up my node editor. So my multiply divide node, and I think 2.5 is right. If it was bigger, I might have to take 1 and divide it by 2.5 to get the actual number, because that would be a slower gear. But because we're doing the smaller one, I think we should be able to do this. Oh, and it needs to be negative 2.5 again because it's going to rotate the opposite way of the bigger gear. Okay, let's try this and see if I fumbled my way through that. Oh, great. Yep, there we go. So anyway, there's a taste of how to get gears working. You can see it's pretty simple. It's just more about knowing the math on how to make gears in the first place. But the actual rigging of them is super simple. There's some more complex stuff when you start talking about like, screw gears and things like that. But, your basic gear is pretty simple if you just know how you need to make it. Now, if you did have something that you want bigger teeth on, the way you do that is the same way you do in actual gears, is you have another gear that's riding the axle of this gear that then has the bigger teeth that you want, that has a different diameter that then could hit another gear with different teeth. So if that's the kind of thing you're building, just keep that in mind, that, go look at a watch and how the gears kind of stack, or anything else with gears actually. If they have something that has different teeth size, it's usually on a separate gear. But the one that it's actually spinning with has teeth that are the same size. So that's the main key, is just, teeth need to be the same size, so you need to do a little bit of math to make sure that that actually happens. So hopefully that was informative for you guys. Like and subscribe if this stuff is helpful for you. Leave a comment if you have any questions or there's a video you'd like to see. And keep up the great work.